We got us a good old hayman in the shop. If you guys don't know what a hayman is, it typically starts something like a phone call and they go, "Hey man, I got something for you. It's real simple. Take you 5 minutes tops." Not always guaranteed 5 minutes tops, but sometimes you get lucky and it doesn't take that long. So what we have here is a cylinder head off of a Jeep engine. I don't know anything about Jeep engines, so I bet you some of you guys will recognize this. It's a 4-cylinder. I just don't know what displacement it is. So it's got a broken bolt. You have your exhaust manifold that goes on here, and this very last bolt that they said right up against the firewall was broken off in there, and I believe it came in because of this reason. They said that the customer was complaining that it had a really bad exhaust leak, and obviously you can't bolt down the exhaust manifold very well with a broken bolt. They said that it was already broken off in there, so they didn't even break it off trying to get the manifold off. They found it, and luckily they haven't tried to go in there and drill it by hand and break drills and taps and easy outs down inside there. This job is going to be for a longtime friend of mine named Phil. I've done a lot of projects for him that's been featured on the channel over the years. Him and his guys, they got a awesome shop where they work on Jeeps and custom builds and all kinds of different things automotive related. So usually when he comes into a project like this that he needs a little bit of machining help on, he'll reach out to me to see if I have time to mess with it. And if I for some reason can't get to it, he's got another guy in town that he will call, and Van, he'll help him out sometimes as well. But I appreciate them not coming in there and trying to get this out themselves, because it just creates more of a problem whenever you break cutters inside a broken bolt. So I was going to point out, this came in yesterday, and I went ahead and sprayed it down with the CRC knocker loose, and it filled up that what's left of that cavity in there. And I come in this morning, so it's been soaking all night with the knocker loose, and I can see that it went down through the bolt. So that's a good sign. It looks like the knocker loose is doing its job. It's penetrating. I'm going to go ahead and put a little bit more on here and let it soak a little more while we're getting things set up and get it ready. So I'm not using the drill, the welding technique on this. I know that guys with skill can come in here and TIG weld the end of that, build it up, weld a nut on it, weld things to it, try to get it out. That's the mechanic trick to do it, and I've done it myself many times. But I just prefer, when I can, if it's going to be a difficult bolt to get out, to go straight to the machine and use the drills to try to extract the broken bolt. Or if you can't get it extracted, you're already set up, you can finish drilling it out and either peel the thread out or just cut it out however you need to. And hopefully this is going to be pretty simple. I'm going to start with our left-handed drill. So we'll get it centered up, we'll flatten it out with an end mill, drill a little center in the center of it, a small hole, and then we're going to go in with our left-handed drill to see if it'll hopefully break its bond loose and unscrew it while we're trying to drill it with our left-handed drill. And I'm hoping that the knocker loose there has helped break the bond loose that's in there. I don't know why the bolt is broken. It could be bottomed out in there. Sometimes when a bolt has been torqued all the way to the bottom of the hole and it's bound up in those threads in the bottom, that using a left-handed drill or even easy out does not get the broken bolts out. Sometimes you just have to drill the thing out of there. So we're going to go to our KBC milling machine and get this guy set up and see if we can extract this bolt here. I did want to point out that it is 3/8/16. Already verified it with a tap. And so we'll clean these holes up, run a tap in there. And they asked while I had it if I would go ahead and inspect this gasket face here. I've got a straight edge that I can use to make sure that it doesn't have any kind of, maybe it needs to be decked. I don't know. They just said check it with a straight edge and let them know what I find. All right. So we'll go over to the mill, start getting this guy set up. I poured my knocker loose out, and we'll see if we can get a broken bolt out of this guy. I was doing some verification to see if all of our machine surfaces were square to each other. So I can tell that those two surfaces are square. Okay. right there, and then on the other side, so 180 from our broken bolt side, which is where we're going to be sitting down. If I flip it up, you've got these machined areas right here, which I'm hoping is square to our gasket face side, the piston side there. And just putting my machined square up there. It looks, just visually, it looks like it's nice and square. I mean, it may be out of touch, I'm not sure. It might be what's, you know, what this is sitting on there too. But I think it's going to be square enough where we can actually set the thing down on this face, since that's a machined surface, and then maybe we can get in here with an angle plate or something on either side. And well, there's nothing to bolt through there. Just put an angle plate maybe on the back of it and use a clamp to hold it up. Just trying to get it inspected to see how we're going to be able to set it up and hold it in the mill. Okay, we're getting it set up on the KBC knee mill here. What I did was I just used a couple of angle plates there on the back, and I had enough room where I could just set up a couple of toe clamps to pull it up against the face of the angle plates there. So we've got that nice and tightened down. And I've already begun inspection, and what I'm doing, I'm using the test indicator here to sweep across this face to see if it's square. And unfortunately, it's not perfect. I'll go ahead and sweep this for you. So we got a distance of about 2 inches there. And as we sweep the test indicator across, we're getting about right at 0.004 difference there, high and low. So it's dropping down as you go across. But what I'm saying is that that is going to be flat enough and good enough for extracting a bolt, drilling a bolt out of there. That's not going to be critical for that. Now, if you're wanting to deck this surface, machine this off, obviously that needs to be as parallel, straight and flat as you can get it. But we're not working on the surface. We're just going to be drilling a hole there. So this is going to be fine how we have it set up. And we'll go ahead and break this down and go ahead and start getting centered up on that bolt hole there. I wanted to point this out. One of the cool things about the Starrett number 811 test indicator is that you have a dial face that you can reposition. So make it either vertical or horizontal or at an angle, whichever way it configures works best for you. So I really like that feature of this. So you can come in here and sweep a hole and have the bezel, the dial face pointing up so that it's not coming around and you got to use a mirror or come in behind to look at it. You can just point it up like that. Or if you're down here more of in a horizontal position and sweeping across the top of a face in a different configuration, you can just pivot it down like that. And the dial face is always pointing up at you whenever you're using it. So super cool test indicator that Starrett makes, the number 811. Whenever I go to center up on a hole like that we want to get center up in and flatten the broken bolt out, I like using a 2-flute end mill. And I thought I would show you this because I just did this. This might be very helpful. I've got a couple end mills. I got a 3/8 and a 5/16 that I just cut in half. Now these were, this was a double-ended 2-flute end mills, okay? And these are some that a viewer gave me a while back. I got them in this drawer right here. A viewer had sent me this container full of brand new old stock high-speed steel end mills and center drills and things like that. And I've been using these in the new shop whenever we need. So I can't remember who sent that, but that was totally awesome. And I haven't made these yet for the new shop, so I just thought I'd point this out. So take a double-ended end mill. You can use a single end, but I like the double end because then you get 2 out of there. And then you take that, cut it in half. You can put this in a collet or a drill chuck. And then you can use these to come in here and center up your hole. Just rotate your spindle and just line it up by sight until you get it close. We got a 5/16 right there that you can use if you want to get down inside there a little bit further. And then once you get it centered up, lock the table in place, and then use this just to kind of make your flat whenever you go to do your drilling. So helpful little tip. These are tools that I only use for doing this one operation right there, is just flattening out a broken bolt. All right. I already had the 3/8 collet mounted up in the collet chuck there, so we just use that to hold the end mill. So we're going to use the 5/16 to try to line up this hole. I put it in neutral so that you can spin it, and I position the flute so that they're this way in X, and then I turn it so that they're that way, and then that's your movement. So you're just kind of eyeballing the edge of the cutter with the edge of the hole. That's all you're doing. It's just more of an eyesight alignment there, and you can usually get it really close that way. So we know we need to go to me slightly, and we need to go that way slightly. That looks like that's pretty good. In fact, since we've actually got some of the larger bit of the hole there available, so we might just go ahead and put one of these 3/8 in here. Let me look at it again. That's lining up more closely to the chamfer that was machined on that hole. So I think I'll swap the 5/16 out for the 3/8 and see if we can line it up on that chamfer. You just want to try to get as close to the center as possible. Dead center is always the best outcome, but as long as you can get it really close, I'd say within 10 thousandths or less, it's kind of ideal what you want. It'll just make the job go that much better. And of course, you don't want to drill into the existing threads. That's why you want it on center there. Put it back in neutral. Same thing, we're just going to come right down on that chamfer, and I'm going to eyeball it. I mean, that looks pretty good right where it's at. Rotate it that way. It looks like I'm already in the center using the 5/16, so that's good. But I'm going to go back with the 5/16 so I don't actually cut the 3/8 diameter down inside the hole. And then we'll use this to flatten the broken bolts out. And you want to flatten it if you can. It's always best. That way your drill will start straight and it doesn't taper off as you're trying to drill the hole out. So at the beginning of this, I was talking about how this is a Hayman, right? Well, check out what just showed up. Another Hayman. Look at that. Totally unexpected. This belongs to a local guy that actually found me on YouTube, and he can't find anybody to help him do this. So he was kind of desperate and asked me if I could help him. It's an intake manifold off of a Chevrolet 350, and he needs these holes drilled out right here because they're drilled at an angle that looks like 90 degrees to this face right here, but apparently they have some that are drilled more straight in line down that way. So he's trying to get his food truck engine together for the spring, and he needs these drilled out. So this is not something that I'm real familiar with, but we're going to drill them out and give him some clearance so that he can get this. This is an Edelbrock, I believe. Get that Edelbrock intake bolted down. He says the way it's made is that the bolts got to go a little bit more straight in line. So we're just going to drill these out for some clearance so he can get his bolts in there. Anyway, I just thought that was kind of funny. It showed up unannounced, unexpected, and I'll work on this later and see if we can get him fixed up. All right, let's see if we can get our bolt flat. If it tries to spin down into the hole, that's actually a good sign. That means that we should be able to get it out fairly easy. Just nice and easy. I'm not pulling down very hard on the quill handle here. And it looks like we've got a nice flat surface to work with there on our broken bolt. I am going to start with a center drill purposely so that we can get a nice center hole down in the center right there. Just going to put a little dab of anchor lube right there to help lubricate that tip. Nice and easy. You don't want to break it. I'm trying not bolt to spin. I want it to spin, but I want to do it whenever I'm using my left-hand drill. All right. This is a 1/8 diameter left-handed drill. We're going to use it to put a small hole down through the center of the bolt, and left hand just in case it helps try to crack it loose. It's not very far in there. Felt like maybe a quarter, 3/8 thick total. We'll go ahead and try our larger left-hand drill now. Next up, we got a 1/4 inch left-handed drill in there. We've got it spinning in low gear at about 150 RPM. Our hopes is that it's going to catch that broken bolt and spin it out. And it did not. So that thing is stuck in there pretty tight. So now we're just going to have to drill the thing out. Next up, we got a 9/32 left hand. We're just kind of sneaking up on that tap size of 5/16. I'm assuming that maybe the threads are galled together and why it's not coming out of there. Sure does not want to spin out. Okay, this is tap size 5/16. It's fighting us all the way to the end. I'm going to see if there's a chance of maybe peeling some of the thread out with this pick first before we run the tap in there. You can see it trying to come out. Let's try to see if we can unpeel it here. There's what's left of your broken bolt right there. All right, we want to run the tap down in that hole and these other holes there as well. I'm going to use the anchor lube to lubricate the tap. Doesn't take much. Spring center just in case we need it. Keep it nice and straight. Cleaned up the hole nicely. All right, well that turned out great. We did not get into the threads. I don't see any cut marks where we cut the point of the threads. So our job is done, but I am going to go ahead and take our tap and just clean up the rest of these holes right here while it's positioned right here. And then afterwards, when we pull it out, I want to go ahead and and check that piston surface right there, and use a straight edge just to kind of gauge it and see if it's straight and flat. Another cool side effect of the anchor lube, whenever you're just cleaning holes out like this, it's got a little bit of corrosion in there. It helps capture those rust particles that it's scraping out of the thread and sticks to the tap. It just sticks to the inside flute of the tap right there as you're cleaning it out. So it helps pull the rust out, and you take your air nozzle and just blow it off. Put a little more anchor lube on it. Keep working down the line here. So as we finish this up, some more thoughts on broken bolt removals. You know, I've showed broken bolt removals several times throughout the history of my channel. Some we've had really easy success with. Some have had challenging side effects to it, and there's definitely any number of ways in which you can use to get a broken bolt out. Typically what I see in the comment section is people saying that all I've ever done is weld to it, weld a nut on it, comes off every time, guaranteed. It is not guaranteed to get a broken bolt out just because you heated it and welded something to it. I'm saying that because of my own personal experience. I'm not saying that I'm any better than anyone else at doing this kind of work. I'm just saying from my own experience. When someone says guaranteed to work every time, it's guaranteed to never work whenever someone says that, okay? So I've had many jobs where Dad and I, we've come in here and we've welded on it. It's a lot easier when the bolt is sticking out of the hole. And what we would do, we would lay a washer over that and then weld to the washer, get it welded nice and solid, and then we would stick a hex nut on it and weld the hex nut to it. And that has provided good results many times, but there are just some cases where that bolt is not coming out of that hole no matter how much you heat and beat and twist on it. It's just the nature of the beast. Sometimes they come out easy and sometimes they want to fight you. I've had plenty of them go both directions. I wish we had a camera whenever I was working with Dad, all the stuff that we did over the years, but I mean, that was during the times that nobody took video of anything machine work related. YouTube didn't exist. Social media didn't exist. So just good memories and good experience. All right, all of our holes are now clean, and we're gonna go ahead and get this guy unbolted, and then we'll do a quick check on this other face here and see if it's flat. I'm gonna go ahead and break this down. I'm gonna point out I keep these wedges around. These are super handy for all kind of stuff, but they allowed me to hold this thing up since it's got a little bit of an angle right there, or inconsistency in the cast, I mean, so that when you unbolt it, it kind of like lays over, and that just, those wedges hold it in place. Just want to hold these so they don't fall down and hit the table. Like that. All right, there we go. I'm just going to very gently hit this with the wire wheel just to remove any kind of surface contaminant so it doesn't mess up my measurement with our straight edge. I'm not doing a full cleanup. I just want to make sure that we don't have any raised areas from a gasket or something on there messing up our reading. There was a little bit of gasket left right. That should be good. That's where I need my wedges again. All right, I'll go get the straight edge we'll see what kind of reading we can get on that. All right, so I have a straight edge here. This is an actual straight edge, and I even had it touched up. One of our viewers a while back, Pete, I believe, he's the one that actually touched this up on the surface grinder, so we should have a nice straight edge. I keep it laid flat in the toolbox there. And we're just going to lay this across right here. I think I see a little gap in there. All right, so I'm going to take our feeler gauge set here, thickness gauge. Let's pull some of these leaves out and see. We'll start with about 5 thousandths. So I've got a 5 thousandths feeler gauge. Do it on this side so you guys can see it. Trying to go underneath there. All right, let me try. We'll swap this around. Let's pull the 4 thousandths leaf out. We'll do a 3 and a 2 as well. So there's our 2, 2.5, 3, and 4 thousandths thickness feeler gauge. 4 thousandths is sliding underneath there. 3 thousandths right there. 4 thousandths in the middle. 3 thousandths there. And it should be touching on the end. So I'm going to call it 4 to 5 thousandths. It could be 5 thou because it felt like it was trying to go. All right, so we've got 4 to 5 thousandths bow in the cylinder head. I'm not an engine machinist, so I don't know if that's good or bad. Obviously, you want as flat as possible. So I'm just going to relay this information to Phil so that he can make the decision whether they're going to bolt it back on there or they're going to have an automotive machine shop deck this thing off properly. That's not something that I typically deal with. I usually send stuff like that out to the guys in town that deal with cylinder heads every single day. So I just called Phil to let him know the cylinder head is done. He's going to come and pick it up. And I told him what we found here, checking it with our straight edge and our feeler gauge, that we have a 4 thousandths gap here on the gasket face for the piston. And he thinks that that is going to be fine. They had no problems with the cylinder head leaking. And, you know, they're going to be putting a brand new gasket on this there as well. And he thinks that that's going to be fine. The main culprit was the broken bolt, and the header right here, the exhaust manifold, was leaking on that side where that broken bolt was. So he feels it's going to be fine. I don't know offhand what the specifications are on the allowable tolerance in which a cylinder head can be out of flat like that. Maybe you guys in the comments, I'm sure some of you guys are well aware of that kind of stuff, but I just don't know what that is. But we got our job done, and let me move my tools out of the way so I don't mess them up there. But we got our broken bolt out right here. That is good to go. We cleaned up all the threaded holes, and I think that they got a good gasket face there for the cylinder head. So this job is done, and I hope you enjoyed. I think that video of getting the what was left of the thread, peeling it out of there, I haven't watched it yet, but I think that turned out to be a pretty good video, and hopefully it was kind of like one of those satisfying videos for the content here, you know, our project video. And hope you guys enjoyed, and I hope you come back for the next project. All right, see you guys later.